Troubleshooting cable and connectivity issues. Understanding limitations. Overview. Troubleshooting cables refers to the necessity of knowing the cable's maximum length and bandwidth capabilities, which are crucial for ensuring proper network function. Example: if a network utilizes Cat5e cables that exceed the recommended 100 meters, the signal may degrade. This can lead to slow network speeds or intermittent connectivity, hindering overall network performance. Assessing throughput. Overview. This involves measuring the actual rate at which data is transferred across the network. The throughput is significantly influenced by both the quality and type of cabling used. Example: in a scenario where substandard or outdated cabling is used, such as using Cat3 cables in a modern network, the network's throughput will be severely limited. This results in slow data transfers, buffering during streaming, and potential disruptions in VoIP communications. Evaluating cable specifications and dB loss. Overview. This entails defining the performance characteristics of cables, including the acceptable levels of signal loss, which are measured in decibels dB. Example: a network might experience issues if cables with high dB loss are used, such as an older or lower quality fiber optic cable. This could manifest as reduced internet speeds or dropped connections, especially over longer distances where signal loss becomes more pronounced. Identifying interference. Overview. Interference in a network can include electromagnetic or radio frequency disruptions that degrade signal quality and, consequently, network performance. Example: a common instance of interference occurs when network cables are run parallel to electrical cables, which can introduce electromagnetic interference (EMI). This EMI can cause erratic network behavior, such as intermittent loss of connectivity, corrupted data transmissions. Common cable and connectivity problems. 1. Incorrect pinout. Understanding incorrect pinout. This refers to the incorrect arrangement of wires in a cable connector, which can prevent devices from communicating properly. Example: if a technician mistakenly wires an Ethernet cable in a non-standard order, devices may not establish a connection, leading to a complete network failure. 2. Bad ports. Recognizing defective ports. This issue pertains to a defective port on a networking device that can disrupt connectivity. Example: if a router's Ethernet port is damaged, perhaps due to physical impact or electrical surge, it may not recognize cable connections, leading to a lack of internet access for connected devices. 3. Open short. Identifying cable integrity issues. Open or short issues in cabling indicate either a break in the cable open or an unintended connection between wires short, leading to signal loss or interference. Example: a cable damaged by physical stress, like being pinched in a door, may cause an open circuit, resulting in no connectivity, or a short circuit, which might intermittently disrupt communications. 4. Lead status indicators. Utilizing diagnostic indicators, lights on networking hardware that provide information about the device's status and activity. Example: a blinking orange light on a network switch can indicate a problem with the connection, such as a speed mismatch or physical connectivity issues, prompting further investigation. 5. Incorrect transceivers. Understanding transceiver compatibility. Using the wrong type of transceiver can cause compatibility issues and communication failures. Example: Installing a single-mode fiber transceiver in a system designed for multi-mode fiber can result in no transmission of data, as the light wavelengths used by the two types are incompatible. 6. Duplexing issues. Addressing duplex mismatch. Problems that occur when the send and receive data rates are mismatched in a network. Example: if one device is set to full duplex and another to half duplex, this mismatch can cause collisions and packet loss, evident in slow network performance and data transmission errors. 7. TX-RX reversed. Correcting reversed connections. Transmit TX and receive RX connections being swapped disrupt the flow of data. Example: in a fiber optic connection, if the TX and RX are reversed, the system will not function, as the transmitting end of one device will be trying to communicate with the transmitting end of another, leading to a complete lack of communication. 8. Dirty optical cables. Maintaining fiber optic cleanliness. Contamination on the fiber connectors leading to signal degradation or loss. Example: dust or dirt on the end of a fiber optic cable can scatter or block the light signals, causing significant data transmission issues, such as reduced bandwidth or complete loss of connectivity.